I'm Alex Brown, and I'd like to introduce you to the Shear and Moment Comparison Design Tool. This simple but effective tool allows you to analyze existing joist for revised loading and get visibility on where reinforcing may be required. Let's jump in. So the first thing I'd like to point out are the three buttons across the top: Inputs, Shear Diagram, and Moment Diagram. And these are going to be our primary ways to navigate through the tool. Right now we are on the Inputs section here, but once we have some information in there for the design loads, it'll generate a shear diagram and moment diagram for us. There's a couple of fields here that are optional. You can fill them out if you want those on the final printed output. And then the big thing here, on the left-hand side is this original joist design load section. And then on the right-hand side is the revised joist design load section. And that's where we're primarily going to be focused because that's what's going to generate all of the diagrams and the information later. So let's go ahead and jump in with a real example. Let's figure a 40-foot joist span, 0 inches. If I did have a fractional amount of inches, I could input that here up to the 1/8. And then for the uniform load, let's just figure 280 PLF. Maybe we had the original drawings, so we know that's what this joist was designed for. And per the SJI spec, that joist is going to have a minimum shear of 25% of the end reaction. And we'll see that in the shear diagram in a second. And that's all this joist was designed for in our hypothetical here. But now, maybe we're peeling some of the roofing material off, so the uniform load is going to get lighter. Let's figure 240 PLF. And now we're going to add an RTU, and we've got some snow drift loading that wasn't present before. So let's go ahead and punch some values in here. RTU can be at 8 foot and 12 foot from the left end of the joist, measuring to the right. So about 8 foot and about 12 foot along our span where the mouse is there. And just 1.5 kip magnitude for both load locations. For the snowdrift load, let's figure at the right end of the joist, just a triangular load, starting at 0 and kind of tapering up to our maximum load magnitude. So we can start that at about 28 feet, 0 magnitude. And then for the length, if we try punching in something like 15 feet, we're going to get an error that the starting location plus length must be less than or equal to the joist span. And that's simply because 15 feet plus 28 feet is greater than our 40-foot joist span. It would run off the end of the joist on the right end here. So for the length, we'll put it at 12 feet so that our ending load magnitude of 200 PLF is right in line with the end of the joist there. And that's it for inputs. We can go ahead and hit the shear diagram button to start generating some of that information. And the first thing here, a lot of lines, a lot of colors. So let's talk through them one by one. The blue line here, this is the shear due to our original loads. So you can see that's just a straight line because all we had was that 280 PLF uniform load. The green line is the shear due to our revised loading. And I can see the discontinuities here, the two of them, because of those RTU loads. On the right side here, you can see it start to kind of taper off as it applies that non-uniform distributed load, that triangular snowdrift load that we put on there. In the middle here, this is where that minimum shear comes into play, that 25%. So that's 25% of the end reaction. So 1.4 kips is our minimum shear value. That's simply 25% of 5.6 kips. And you can see that just kind of punched in here as a minimum size for the webs. But these red lines here, this is where things are really important. This is where the tool is recommending web checking. The webs within these ranges here, so most of the span, except for maybe a short distance here between 10 and 20 feet, the webs need to be checked for possible reinforcing. And just, they are not capable of carrying the revised loading. And if I want to dial in like what that distance is between that gap, if I hover over here, I can see that my X coordinate is about 12 feet. And then down here, that X coordinate is about 17.6 feet. So there's maybe a 5-foot section here where the webs are probably okay, but at this rate, it may be worth just checking everything on the joist. And if I jump to the moment diagram tab, structured very similarly, I've got my original moment line, my revised moment line, and then the red here is just across the entire span. Because it's the moment, joist chords typically carry the moment. So this would be the top and bottom chords of the joist need to be checked for potential reinforcing. And that's the shear and moment comparison tool. It's a great resource for comparing as-built original loads to new revised loading and seeing which parts of the joist may require further attention. And it allows you to efficiently use existing joists out in the field. And with that, happy specifying.